In this lab, we look at the cement data. An Auckland concrete manufacturer explored the way that the hardness of concrete relates to the amount of cement in the mixture. Forty batches of concrete were made with varying amounts of cement in the mix, and the hardness was measured after 7 days. This data comes from the Chance Encounters Wild in Siba 2000. So cement and the hardness is given. Describe the relation between hardness and the amount of cement. So to describe the relationship, we need to find the correlation coefficient. So we'll type equal correl. We can also plot the scatter plot and to find the relation between hardness and the amount of cement. So click on an empty cell and click on insert, click on chart and select scatter plot. Let's move this to a new sheet, edit, and now let's label this as rename the chart as scatter plot. Now for the data range, let's add the data range. So first select the independent variable, cement. Then add the dependent variable, hardness. Click on OK. Now let's give it a title. The vertical axis title will be hardness. And the horizontal axis title will be weight of cement. And the weight of cement is in grams. Then it's the horizontal axis title. And for the chart title, let's have concrete hardness versus amount of cement. And for the vertical axis, let's have the minimum value 0 and the maximum value 60. And the horizontal axis, and let's have the minimum value, say 150, and the maximum value, say 400. let's have the tick marks. So grid lines and ticks. For the vertical axis, we'll have the ticks in steps of 10. So major step 10, and we major ticks. And for the horizontal axis, we'll have the ticks in steps of 50. Okay, so from the graph, we can see that it shows a strong positive relation. So, strong positive linear relationship. What is the correlation coefficient? To get the correlation coefficient, we'll type equal correl. We'll choose the dependent values, which is for hardness, comma, then choose the independent values, which is for cement. Close the bracket. So it's about 0.968, the 3 decimal place. Do you think that this relationship is causal or spurious? So it's a causal relationship since the extra cement is causing the concrete to be harder. So from the scatter plot, we see as the weight of the cement increases, the hardness increases. So it's a causal relationship. What is the coefficient of determination? So the coefficient of determination is equal to square of the correlation coefficient calculated in two different ways from the output. So, and interpret the results. So we can also calculate it by finding the regression equation. Let's find the regression equation. Equal lineage, then choose the dependent values, comma, then choose the independent values. So the regression sum of squares, we want to find the regression sum of squares. To find the regression sum of squares, we need to find the predicted values of the hardness. So equal the y-intercept plus the coefficient of the variable multiplied by the cement values. And the intercept remains same, so put a $sign in front. And the coefficient of cement also remains same, so put $sign. And then copy the formula to the rest of the cell. Okay, then we find the residual. So equal hardness minus predicted hardness. Equal hardness minus predicted hardness. And copy that formula to the rest of the cell. Then take the square of the residuals. Equal bracket residuals, take the square and copy that to the rest of the cell. Then find the total of the residuals squared. So equal sum of, select the residual squared cells. Then we find the mean of the hardness values. So equal average of the hardness values. Then we subtract the mean of the hardness from the hardness values and take the square of those values. So equal bracket hardness minus mean of the hardness, close the bracket and take square. Now the mean remains the same, so we will put $sign in front and we'll copy this formula to the rest of the cells. Then we'll find the sum of the hardness minus mean of the hardness squared. So equal sum of all those values, press enter. Now to calculate the coefficient of determination, the regression sum of squares is equal to the total sum of squares minus the residual sum of squares. And the total sum of squares is 5647.375. And then what we do is that we divide. So we divide the regression sum of squares by the total sum of squares. And that's 0.9362726.468, which is the same as the one that was automatically calculated by the spreadsheet. Interpret the results. This shows that about 93% of the variation in hardness is explained by this linear relationship with the weight of the cement. Write down the equation of the regression line, interpret the coefficients, and draw this line on the graph. So hardness equal to, so 3 decimal place, minus 24.178 plus 0.187 times weight of cement. And interpret the coefficients. Minus 24.178 is the concrete hardness when there is no cement. For each extra gram of cement, the concrete hardness increases by 0.187 units. And draw this line on the graph. So we have a scatter plot drawn over here. So if we edit the chart and if we click on customize and then the series, we tick the trend line and we show the R squared and that's 0.936. How much would you estimate the hardness would increase if the amount of cement used was increased by 20 grams? So if the amount of cement was increased by 20 grams, then the hardness would increase by, so let's calculate what would the hardness increase by. So type equal, so 0.1866884187 multiplied by 20. That's about 3.73 grams. Predict the hardness of concrete made with 275 grams and 600 grams of cement. Comment on the reliability of these estimates. Now for 275 grams, so we'll type equal the intercept value plus the coefficient value multiplied by 275. Okay, so now for 600 grams, let's the intercept value doesn't change, so you put the $sign in front, and the coefficient value also doesn't change, so you put the $sign in front. And that's 600. Now for the predict the hardness of the concrete made with 275 grams and 600 grams of cement. So it is about 27.16 and 87.84. And for 275 grams, it is in the observed value weight of cement range. So that's interpolation and that's a reliable data. But for 600 grams, it's extrapolation data. So it's out of the range of the weight of cement that has been observed. So it's unreliable. What does the residual plot tell you about the suitability of using a linear model of this data? So let's click on the empty cell. We have already found the residuals. Let's plot it. So let's click on insert. Let's click on chart, and we want let's move this to the on sheet, and let's select the data range. So first we select the explanatory variable, the independent variable, which is cement. Then we add another range, which is for residuals. There should be a scatter plot. Okay. So now let's label this data. The title, let's put residuals versus cement. And for the horizontal axis, let's put cement, and let's have that's in grams. And for the vertical axis, that's hardness. And the cement values, let's customize the value, minimum and maximum. So horizontal axis, the minimum, let's have 150, and the maximum, let's have 400. And for the vertical axis is all right, but the grid lines and ticks, let's have for the horizontal axis, let's have that in steps of 50, and for the vertical axis, let's have that in steps of 2. And we'll show the tick marks, and for the horizontal axis, we'll show the tick marks. And for the vertical axis, let's have the minimum as -10 and maximum has 10. Okay, so what does this show? So we can see that the residuals are randomly distributed around the zero line. Random scatter suggests that a linear model is appropriate. So the residuals are randomly scattered around the zero line. It shows that the linear model is appropriate. Let's rename the residual chart. Calculate the residuals for the first 2 batches of concrete with 365 grams and 220 grams of cement. So from the residual plot, for 375 grams, 365 grams and 220 grams. So for 365 grams, we have 1, 2, 3, 4, 5, 6, 7 residuals. So for the phase 2 batches of concrete. So the residuals have already been calculated, and for 220 grams, we have 4 values of residuals, and they are below 0. But for 365 grams, the residuals, 2 of those values are above 0 line, and 4 of those are below 0 line, and 1 value is approximately on top. So it's very close to 0 line.